A batch of 2,000 electronic components has been shipped to a buyer. The rate of defect is known to be 12% for this particular electronic component. So it is expected that there will be 240 defective units. The buyer will select 3 without replacement and test them for quality. If all 3 pass, then the entire batch is accepted. If any of the tested items are found to be defective, then the entire batch is sent back. What is the probability that the entire batch is sent back? It would be a good idea to draw a probability tree in order to understand this problem. A selection is going to be made, and that selection could be a unit that is good or a unit that is bad or defective. Then, without replacement, a second selection will be made, and that selection will be either good or bad. Then a third selection will be made, and that selection will be either good or bad. So this tree shows all of the possible outcomes for this experiment. Now we're asked for the probability that the batch is sent back, which means that if we were to, in this process, find any one of the components to be bad, then it would be sent back. So we're really looking for the probability that we would have at least one bad or defective unit. But if we look through this tree, that would be every branch except this top one. So really then, this event and the event that we would find 3 good ones are complementary. So this then would be the same as 1 minus the probability that we would have 3 good units. Now we're told that there are 2,000 total and 240 of those are defective. So on this first selection, the probability that we would get a good one would be 2,000 minus 240, which will be 1,760 out of 2,000. Then, of course, the probability that we'd have a bad one on the first choice would be 240 out of 2,000. But we're not real concerned with that because we're only going to think about this top branch here. Now, we're not going to put that one back. So the probability that we would get a good one, given we got a good one on the first draw, would be 1,759, 1,759 good ones left, out of 1,999, because there's one now that has been removed from the batch. And then we would continue here. We'd have 1,758 out of 1,998. Now the probability that we would get 3 good ones means we would get a good one and a good one and a good one, not a good one or a good one or a good one. This would be the word "and" that we would use here, or the intersection symbol. And that implies multiplication. And we've already seen that what we do to get to the end of a branch of a tree is multiply. So we're going to have 1 minus this probability of having 3 good ones, which again will be multiplying these 3 fractions together. 1 minus 1,760 out of 2,000 times 1,759 out of 1,999 times 1,758 out of 1,998. And if we round this to 4 decimal places, we will have 0.3187. So that is the probability then that we would send the batch back. Another way we could interpret this is that if we were to perform this experiment over and over and over, in other words, taking a batch of 2,000 and selecting 3 without replacement and testing them, then 31.8%, or rather 31.87% of the time, those batches would be sent back.